This higher tier section is about energy resources and transfer. It covers work, power and energy, and more about electromagnetic effects. First, work, power and energy. In the foundation programme, we looked at the work done by a weightlifter lifting some weights. The work done lifting the weights depends on the size of the force and the distance the force moves. The equation for this is work done equals force times distance. The unit of measurement for energy and work done is the joule. So the work done in joules equals the force in newtons times the distance in metres. There's another useful measure of work and energy, and that's power. Power relates the work done to the time taken to do it. The quicker it's done, the greater the power. The formula for this is power equals work done divided by the time taken. The unit of power is joules per second, or watts. If our weightlifter lifts a mass of 50 kilograms, 2 meters off the ground in 4 seconds, what is the work done or energy transferred by the weightlifter, and what is the power input? The first part of the question asks for the work done or energy transferred by the weightlifter. That's the force applied times the distance lifted. That's the mass, 50 kilograms, times the gravitational field strength, 10 newtons per kilogram, times the distance lifted, 2 meters, which is 50 times 10 times 2 equals 1,000 joules. The second part of the question asks, what is the power input of the weightlifter? Power is the rate at which the work is done in joules per second. So that's 1,000 joules divided by 4 seconds equals 250 joules per second, or 250 watts. What happens if the weightlifter drops the weights? The weights fall to the ground, losing potential energy and gaining kinetic energy as they fall. When they hit the ground, the kinetic energy is turned into sound energy and some heat energy. For the higher tier, you need to know how to work out kinetic energy. Kinetic energy is the energy of a moving object. Kinetic energy depends on the mass of the object and the speed at which it moves. The formula for working this out is kinetic energy equals half the mass times the speed squared. That's a half mv squared. That's the end of the higher tier section on work, power and energy.